Here's a video for patterns and sequences. So a sequence is a pattern involving an ordered arrangement of numbers, geometric figures, letters, or other objects. A term of a sequence is an individual number, figure, or letter in the sequence. So for each one of these situations, we're going to describe the pattern. We're also going to draw the next three figures in the pattern or list them out. We're going to represent the pattern as a numeric sequence, and then we're going to fill out the table of values. Okay, so if we look at this particular pattern here, we see we have these, I guess they're not really X's, but figures that are in the shape of a plus or a positive. So one thing to do if you're having trouble identifying the pattern is to count out how many in each figure. So if we were to count out the number of dots in this first figure, there would be 25 dots. In the second figure, we count them, there's 21 dots. In the third figure, there's 17 dots. And in the fourth figure, there's 13 dots. So essentially what seems to be happening is that we're basically removing a dot from each part as we go down in figures. So we can say each figure has 4 fewer dots than the figure before it. Okay, so if we were to draw the next three figures, if we look at this one and we cut off the 4 dots here, it would basically be 1 dot in the center and 2 on each side. So 2, 1, 2, 1, 2, 1, 2. My next figure would have 1 on each side. And my last figure would just be 1 single dot. So now it says represent the pattern as a numeric sequence. So we've already kind of done that by listing out the first 4. So starting with the first figure, we have 25. The next one was 21. Then we have 17, 13. The next figure has 4 less than that, so that's 9. 4 less than that would be 5, and then 4 less than that would be 1. And then the last thing says to represent the sequence as a function using the table of values. So starting with term number 1, there were 25. 2, 21. 3, there were 17. 4, there were 13. 5, there were 9. 6, there were 5. And then 7, there were 1. Okay, so if you're filling out your notes, you only need to do 4 more of these, but I'm going to go through each of the different patterns. All right, so the second one is a pattern in words. It says Jessica's investigating her family tree by researching each generation or set of parents. She learns all she can about her first 4 generations, which include her 2 parents, her grandparents, her great-grandparents, and her great-great-grandparents. So let's think about this pattern. So starting with her parents, that's the first generation, there are 2 parents. And then the next generation, those 2 parents both have 2 parents. So that would mean that there were 4 parents in the next set. And then after that, those 4 parents each have 2 parents. So that's going to be 8 parents. And then the next generation after that, all 8 of those parents each have 2 sets of parents. So that would be 16 total parents. So that would be the first 4 terms. So we can actually write that out here. So 2, 4, 8, 16. So what seems to be happening here is each generation has 2 times the number of parents as a generation after it. So we can write that as each generation has 2 times the number of parents. So now we're at 16. So the next one, we would multiply that by 2. Every 16 set of parents would have 2 sets of parents each. That would be 32. And the next 2 after that would be, would be 64. So the next 2 terms would be 32 and then 64. So we've already written the pattern as a numeric sequence. So then let's write it as a table of values. So starting with term number 1, there were 2 parents. At term 2, there were 4. 3, there were 8. 4, there were 16. 5, there were 32. And then at term 6, there were 64 sets of parents. All right, so this one is a group of figures. It says analyze a small number of squares, describe the pattern. So if we count the number of squares here, I believe it starts at a 7 by 7 which means there are 49 total squares. And then we go down, we go 6 by 6, which would mean that there's 36. And then we have a 5 by 5, that would mean there's 25. And then we have a 4 by 4, that's 16. So if we were to describe the number or the pattern, we can say the number of squares are decreasing by perfect squares, beginning with a square of 7. Okay, so if we were to draw the next 3 figures, it would be a 3 by 3 square. And then we would have a 2 by 2 square. And then lastly, we would have a 1 by 1 square. So let's represent the pattern as a numeric sequence. So we start at 49, 36, 25, 16. 3 by 3 would be 9, 2 by 2 would be 4, and then a 1 by 1 would be 1. So starting with, as a numeric sequence, we started with 49, 36, 25, 16, 9, 4, and then 1. All right, this situation says Al's house of eggs makes omelets. Al begins each day with 150 eggs to make his famous best and western omelets. After making 1 omelet, he has 144 eggs left. After making 2 omelets, he has 38 eggs left. After making 3 omelets, he has 132 eggs left. So it says, think about the number of eggs Al has left after making each omelet. Describe the pattern. So let's just list out the first few numbers. So starting at 150, actually let's do it down here. 150, then he has 144, then he has 138, then he has 132. So if we look, we can see that this is decreasing, and it seems like each omelet he makes, it decreases by 6. So there are 6 less eggs after making each omelet. So determine the next 2 terms of the pattern. So if we start at 132 and we subtract 6 from there, that would give us 126 eggs. And then we subtract 6 from that would be 120 eggs. So let's add those to our sequence. So 126 and then 120. All right, so now let's fill out our term values. So we start at 150 and we go down to 144, 138, 132. Term 5 would be 126, and then term 6 would be 120. All right, this says Donna is decorating the top border of her bedroom walls with a daisy pattern. She is applying decals with each column having a specific number of daisies. So think about the number of daisies in each column, describe the pattern. Well, let's just look at each column. This is 3, this is 4, this is 2. The next one is 3, 4, 2. So it seems to be a pattern of 3, 4, 2. So repeating pattern. Of 3, 4, 2. So the next 3 terms of the pattern would be 3, 4, 2. Now we can write it as a numeric sequence. So we have 3, 4, 2. 3, 4, 2, 3, 4, 2. That goes on forever. Now using a table, so term 1 was 3, term 2 was 4, 3 was 2. And then we do again 3, 4, 2. And then if we had a 7th term, it would be 3. All right, so now we have some triangles here. So in this case, we are analyzing the number of dark triangles to describe the pattern. So anytime I see a figure, like I said, I like to kind of write out how many we have. So there's 1 dark triangle, then we have 3, then we have 3, 6. The next one we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this particular case, we know that the number of triangles is increasing. However, it doesn't seem to be increasing by the same amount, right? To go from 1 to 3, we add 2. From 3 to 6, we add 3. From 6 to 10, we add 4. So maybe we can describe this as you add one more triangle than you did the previous term. Okay, so in terms of the next two figures, instead of drawing it, I'm just going to write out the next two numbers just because it's too small for me to fit it. So if we added 4, next one we would add 5. So that would mean that our next term would be 15. And then after that we would add 6. So that would be 21. So as a numeric sequence, we started at 1, 3, 6, 10, 15, 21. So starting with term number 1, we had 1. At term number 2, 3 was 6. Term 4 was 10. Term 5 was 15. Term 6 was 21. All right, this one says Mike is trying to beat his high score on his favorite video game. He unlocks some special mini games where he earns points for each one he completes. Before he begins playing the mini games, Micah has 500 points. After completing one mini game, he has 550. Then he has 600. Then he has 650. So think about the total number of points he gains from the games. Describe the pattern. So it seems like every game he plays, he adds 50 points. So now to determine the next 2 points, he was at 650. If we add 50 to that, he would be at 700 points. If we add 50 one more time, he would have 750 points. So now let's represent it as a numeric sequence. So we started at 500, 550, 600, 650, 700, and then 750. And then using our tables, we have our term values. So started at 500, 550, 600, 650, 700, and 750. All right, so now we have polygon party. It says analyze the number of sides in each polygon. So in this first polygon, there's 3 sides, then there's 4, then there's 5, then there's a 6-sided. So describing the pattern, each figure adds a side to the polygon. Okay, so if we were to draw the next 2 figures, it would be a 7-sided polygon. So I'll try my best for that. Let's see, 1, 2, 3, 4, 5, 6, 7. And then it would be an octagon, which would be 8 sides. So that's like a stop sign. Okay, so now represent the pattern as a numeric sequence. So we started at 3, and then as a function. So starting at 1, or a table, sorry. All right, so pizza contest. Jacob is participating in a pizza making contest. Each contestant has to bake the largest and most delicious pizza they can. Jacob's pizza has a 6-foot diameter. After the contest, he plans to cut the pizza so that he can pass out the slices to share. He begins with 1 whole pizza, then he cuts it in half. After that, he cuts each of those slices in half. Then he cuts each of those slices in half, and so on. So think about how many slices there are on the pizza after he halves the slices. So he started with basically 1 whole piece, and then he cut that in half. He had 2 pieces, and then each of those pieces were cut in half. He had 4, and each of those were cut in half is 8. And he kept going. So let's see. So describe the pattern. He doubles the amount of slices. So the next 2 terms in the pattern, he would have 16 and then 32 slices. So as a numeric sequence would be 1, 2, 4, 8, 16, 32. And now a table of values. So this is similar to the first example we did. All right, so here's the last one, coin collecting. It says Miranda's uncle collects rare coins. He recently purchased a rare coin for $5. So that's the first term. He claims that the value of the coin will triple each year, so multiply by 3. So even though the coin is currently worth $5, the next year it'll be worth 15, and then it'll be worth 45, and then it'll be worth 135. So describe the pattern. For that pattern, we're going to say that the value triples each year. So we would multiply by 3. So the next two terms in the pattern, we would multiply 135 times 3, which would be 405. And then we multiply that by 3, we would have 1,215. So as a numeric sequence, we're just going to list them out: 5, 15, 45, 135, 405, and 1215. And then as a table. So started at 5, then went to 15, 45, 135, 405, 1215. All right, so now just a couple of the problems on the homework. So starting with number 3, we just need to write out the next two terms of the figure. So it looks like this is 1 triangle, 2 triangles, this is 4 triangles, this is 8 triangles. So it looks like it's doubling. So the next one is going to be, let's see, it's going to be 8 squares long. 1, 2, 3, 4, 5, 6, 7, and then we're just going to divide those into triangles. So that'd be 16 triangles, and the next one is going to be 16 long. Let's see if we can fit this. So that's 2, 4, 8, and then cut these in half again. So I think that's 16. Let's count 1, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I drew the lines going in the wrong direction, but that would be 32 triangles. All right, number 6 says Kyle is collecting, on this one, sorry, we're supposed to also describe the pattern. So I'm going to say the number of triangles is multiplied by 4. Or sorry, not multiplied by 4, multiplied by 2. I don't know what I'm thinking. Multiply by 2 each term. All right, number 6, Kyle's collecting canned goods for a food drive. On the first day, he collects 1 can. On the second day, he collects 2 cans, then 4. And on each successive day, he collects twice as many cans as he collected the previous day. Represent the total number of cans by the end of each day in the first 7 days of the food drive as with a numeric sequence. So this one actually seems similar to the previous one. He started with 1 can. On the next day, he had 2 and 4, and he's doubling. So 4 times 2 would be 8. 8 times 2 would be 16. 16 times 2 would be 32. And on the 7th day, we would double that. That would be 64 cans.